Hello. Hello. Am I audible? Okay, unmute yourself.
Yes, sir.
Yes, sir.
What about others? Only 3 people you have joined.
Sir, there are 10 students only.
10 students. Okay, only 10 students are willing to participate in this subject, Introduction to MEMS.
Yes, sir.
And others are related to the optoelectronics, I think so.
Yes, sir.
Yes, sir.
Okay. Okay, so let's start. Before starting this one, okay, let me take the attendance. So, Ankon Gupta. Ankon, what is your roll number?
Sir, 56.
56. Okay. Srishti,
Sir, 18.
18. Supratik,
Sir, 8011.
8011 means lateral.
No, sir. 11, 11 roll number.
Supratik Mojumdar. Supratik 8011. 8011.
Yes, sir. Yes, sir.
Okay. Okay. So let's start this subject. Name is Introduction to MEMS. Subject code is PE EI502. Now, before going to discuss this subject, you must familiar with the objective of this course, and you must know the course outcomes after learning this subject. What will be the outcome? Because if you don't know the outcomes, then what is the purpose of reading this subject or go through this subject? So all of you must familiar with these objectives and the course outcomes. Okay, according to the syllabus of this MAC-out. So let's start with the course objective. Here are the list of objectives. The first one is the ability to provide knowledge of semiconductors and solid mechanics to fabricate the MEMS devices. Now, I will discuss what is MEMS later. First, you need to understand the objectives. The basic knowledge you need to provide of semiconductors and solid mechanics to fabricate this, to design these devices, MEMS related devices. Second is the ability to educate on the rudiments of microfabrication techniques. That is the basic techniques. How can you fabricate the device? Several techniques are involved so that you can educate others to know the process. Ability to introduce various sensors and actuators, because a smart system needs the basic devices called sensors and actuators. Okay. Ability to introduce different materials used for MEMS. Now, to fabricate or to design this type of MEMS based devices, which is MEMS sensor or MEMS actuators, you need to find out the right material. Okay, so you most familiar with the introduce with the different materials those are used in MEMS. Last is the ability to educate on the applications of MEMS where you can use the MEMS based devices or the smart sensors or smart devices can be used. Define the applications. So these are the objectives. Now the course outcomes, that is the CO. Course outcome means after go through this subject, you understand or explain or to familiar with or to make use of certain things. That's why these COs are very important. Okay, course outcomes are very important for every course, not for means this subject. For every subject, you must familiar with the course outcomes. The first outcome or the CO of this subject is to understand the working principle of MEMS devices and their application. You must understand the working principle of MEMS based devices and their application where it is used. And BT1, which is the Bloom taxonomy according to the EICT NB accreditation. So Bloom taxonomy level 1 is matched with this CO. That's why it is related to BT1. Different levels are there for Bloom taxonomy, like BT1, BT2, 3, 4, 5, 6, this way. And every CO must be matched with certain Bloom taxonomy level. That's why it is related to or designated in this way here. BT1, BT5, this way. The second CO is explain the microsensors, micro actuators and their types and their applications. Okay. Third CO is to explain about fabrication processes for producing microsensors and the micro actuators fabrication process. And the last CO is to understand the linear and digital electronic circuits. Okay. And analyze this one also. So these are the course outcomes of this subject. So here is your syllabus. There are 6 modules. According to the 6 module, the first one is the introduction about MEMS. The second is the sensor and actuator part 1. Third is the sensor and actuators part 2. Then the micro machining techniques, those are used to fabricate the sensors, MEMS based sensors. Fifth one is the mechanics of solids which can be used in MEMS. And the last one is based on the material which is used as polymer. Polymer is a very important material to fabricate the MEMS based devices. Another materials are used also, but polymer is the uh, polymer is it is very advantageous to use this in MEMS. These are the textbooks or reference books. I will give you the Xerox or sorry notes or Xerox or any other type of material, because you can't access the library now, so you don't have any books in this time. So I will provide the materials. So microsystems versus MEMS. So there are two terms, microsystem and MEMS. Both are same. Okay. Because in Europe, uh, they are called microsystems. Okay, but in the USA, it is called as microelectromechanical systems. In short form, it's called MEMS. This ME, microelectromechanical systems. Okay, while the European name is more general, it is more general, more inclusive, and in many ways more descriptive. Microsystems, very small system. In actually in case of MEMS, this is very catchy and unique and is taking hold worldwide. Now, so what is MEMS? MEMS is a technology of very small devices. It is a combination of mechanical functions and electrical functions on the same chip using microfabrication technology. Now, MEMS are made up of components between 1 to 100 micrometers in size, and MEMS devices generally range in size from 20 micrometers to a millimeter. Okay, so basically, what are they? It has it has basically three features. So microsystems literally are very small systems or systems made of very small components. Now they do something interesting and or useful. Please mute yourself. Everyone mute yourself. If you have any queries, any doubts, I will ask you. Okay, after ending this lecture. The name implies no specific way of building them and no requirement that they contain any particular type of functionality. Actually, micro establishes a dimensional scale. Electro suggests either electricity or electronics or both, and the mechanical suggests moving parts of some kind. That includes MEMS. But the MEMS concept has grown to encompass many other types of small things, including thermal, including magnetic, fluidic, and optical devices and systems with or without moving parts. So, let's not argue about it. Let us admit that both terms cover the domain of interest and get on with it. Okay. So in practice, that basically it includes three features. One is the first one is MEMS involve both electronic and non-electronic elements and perform functions that can include signal acquisition like sensing or signal processing, actuation, display and control. They can also serve as vehicles for performing chemical and biochemical reactions and processes. Second is MEMS are systems in the true sense. This one, which means that important system issues such as packaging, system partitioning into components, calibration, signal to noise ratio, stability, and reliability must be confronted. Third is MEMS involves actually the most successful MEMS have been those which involve paradigm shifts from the macro way of doing things and more than simply reducing the size of the scale. Examples include like inkjet printer head, which enables high quality color printing at very low cost, and thin film magnetic disk heads, which continue to enable sterling improvements in the mass memory industry. Okay. Other examples include silicon pressure sensor and silicon and quartz sensor for the measurement of acceleration and rotation. Microfluidic devices are beginning to enable astonishing improvements in the speed of biochemical analysis. So finally, some MEMS involve large arrays of microfabricated elements. Uh, examples, as for example, uncooled infrared imaging devices, and both reflective and refractive projection displays. So various elements are uh, present, which uses this MEMS concept. So look into these pictures. So this is basically a bulk micro silicon integrated pressure sensor, the first one, where strain sensing register is present, a diaphragm is there, and the size is very small. This type of, and the second picture, which is basically a surface macro machine integrated silicon accelerometer. This is the accelerometer, and so different actuators can be fabricated using in this way. So I was alarm. Okay, wait a minute. Unmute yourself, alarm.
Yes, sir.
Sign was alarm. He raised his
Sir, your
hand.
voice.
Sanmaz Alam, unmute yourself and tell me. Do you want to ask something? Sanmaz Alam, you have raised your hands. So that's why. Okay. Third is this is the actually inertia sensor uh, on chip, very small chip, which is in micrometer in size. And basically these inertia sensors are very intelligent sensors used in automobile industry, automobile back deployment systems. These are used. Lower pictures are, this is the ant, and ant's leg is which can hold some actuator in this way. So it is so small so that it can fist with ant's leg. Okay, and that is the micro gear actually. Okay, so that is the micro gear which can hold by any ant leg. Okay, so small it is. So that's why it is called meme. So how are they made? Basically, so most memes devices and systems involve some form of lithography based microfabrication, or or some in from the microelectronic industry, and enhance its specialized technique called the micro machining technique. Now, the batch fabrication, that is characteristics of the microelectronic industry, offers the potential for great cost reduction when manufacturing in high volume. Okay, so that is called the batch processing. So lithographic techniques generally require the use of flat substrate. Flat substrate. Silicon is often used even when there are no electronic components in the device, because the tools and instruments needed for microfabrication are designed to match the characteristics of silicon wafers. Okay. So lithography offers in plane submicron precision on dimensional scales from micron to millimeter. Now, thin film deposition and etching techniques in combination with wafer bonding techniques allow patterning of the third dimension, making possible the creation of movable parts. Okay, so the combination of lithography with thin film methods tends to result in structure characterized by extrusion of two-dimensional features into the third dimension. Okay, 2D to 3D. And new fabrication methods provide additional freedom to sculpt more general 3D structures, but these have not yet entered in high volume manufacturing process. Now, because MEMS fabrication usually involves some steps uh, which is shared with the conventional microelectronics, there is an almost reflexive urge to make fully integrated microsystems. So that means integrated circuits that include mechanical or other non-electronic elements on the silicon chip, along with the electronic part of the system. So some manufacturer, what happens? Some manufacturers are aggressively pursuing this technique. They accepted this technique, and however, an alternative strategy is to partition the microsystem into subsystems that are fabricated separately, then assembled into a compact system during the packaging operation. Okay, and so in this way they can make. So here it's a gyroscope, very small, where the suspension areas is there, tiny section is there which can be sensed by the sensor. So it's a MEMS device, gyroscope. Second is then the next part is what are they made of? What are the materials they can so in MEMS can be used? So the choice of materials in a microsystem is determined by microfabrication constraints. Okay, integrated circuits, ICs, are formed with various conductors and insulators that can be deposited and patterned with high precision. Okay, most of these are inorganic materials like silicon dioxide, silicon nitride, aluminum, tungsten. Also, certain polymers are used as well. So, microfabrication that extends beyond conventional microelectronics opens up a much broader range of materials and a corresponding set of additional techniques such as electroplating of metals and molding and embossing of plastics. This can be uh, used. Now, the range of materials for microsystems has now become very broad. This offers many choices. So, one role of the design process is to evaluate the relative merits of different ways of building a proposed device. So, these are the materials. So, polymers are very important material. And how are they designed? So the design of microsystem actually requires the several different levels. On one level, what happened? The designer must document the need and specifications for a proposed microsystem, evaluate different methods by which it might be fabricated, and if the device is to become a commercial product, so further evaluate the anticipated manufactured cost. Okay. And at another level, what happened? For each proposed approach, one must deal with details of partitioning the system into components, material selection, and the corresponding fabrication sequence for each component, methods for packaging and assembly, and means to assure adequate calibration and device uniformity during in manufacture. So it's a very daunting job actually. Okay, it's a design package. So actually, quantitative models play a key role in the design process by permitting prediction of performance prior to building a device, supporting the troubleshooting of device designs during development, and enabling the critical evaluation of failure mechanisms after device has entered manufacturing. So models can be developed by hand in analytical form, or they can take the form of numerical simulations carried out on high-speed workstations. So experience suggests that there is a natural progression from approximate analytical models early in the design cycle to more detailed and comprehensive numerical simulations later in the design cycle. Okay. So next is the application of MEMS. So first of all, it's very important in case of medicines. MEMS is a device that can be implanted in the human body. It can be used to make a surgical tool so that the surgery must be most accurate or in easiest way. Another biomemes are there. So biomemes are used to refer to the science and technology of the operating at micro scale for biological and biomedical applications. Okay. Now the another so health monitoring, in case of health monitoring, it's very important. Okay. Healthcare industry actually, like another examples like disposable blood pressure transducer can be made by this, or or angioplasty pressure sensor can be made by using the MEM structure. Okay. Or catheter tip pressure sensors, or sphygmomanometers, respirators, uh, kidney dialysis equipment can be made using the MEMS technology. Different applications are in these industries like automobile, aerospace, telecommunications, and some consumer products also. Like as for example, in case of automobile industry, so it is used for various purposes, like to build some sensor, position sensor, displacement sensors, like the airflow control sensor, fuel pump pressure and fuel injection control. Now today's technology is based on the BS6 Earth Test 6, which is basically fuel injection control system. Okay, so that can be made by the MEMS sensor, a MEMS technology, and transmission of force and pressure control can be adjusted by the MEMS sensor also. So another is engine coolant temperature and quality sensor, or oil pressure sensor, a tire pressure measurement purpose. The MEMS devices can be used. Um, Fuel pressure measurement purpose. The MEMS devices can be used. So various lots of uh, applications are involved in automobile industry. In case of aerospace industry, like cockpit in cockpit, some pressure sensors for oil, fuel, transmission, and hydraulic systems are used. Um, Safety devices like ejection seat controls can be adjusted by the MEMS devices, or a wind tunnel instrumentation, like as for example, shear stress sensors can be used. Sensor for fuel efficiency and safety, or a micro gyroscope for navigation and stability control, or micro satellites, so, or inertial guidance system, so thermal control system, propulsion systems can be, or radar in case of communication purpose, communication radar systems with very high bandwidth, low resistance radio frequency switches. This can be used. MEMS can be used. Another also is the space environment sensors with micro magnetometers and gravity gradient monitors are used using the MEMS sensors. And in case of telecommunications, like optical switching and fiber optic couplings can be made by MEMS technology, or radio frequency switches, or tunable resonators can be made by using the MEMS technology. And consumer products like scuba diving watches and computers, bicycle computers, fitness gear using hydraulics, washers with water level controls, sports shoes with automatic cushioning control, like digital tire pressure gauges, vacuum cleaning with automatic adjustment of brush beaters, smart toys. So the MEMS application area is a very very vast area. Okay. And nowadays in every areas, in every industry, where you can see the MEMS, use of MEMS with sensors of the devices. That's why all things can be going to be smart day by day. Okay. And basically in case of any microsystem, smart microsystem, uh, you need the basic things like the signal. You need the inputs, so which can be a micro sensing element, needs the micro sensing element. Then you need the transduction unit, so that so different actuators are used to make it smart. So basically in MEMS, the main parts is based on the sensor and actuator. Okay. So that's all for today. And if you have any queries relating to MEMS, you can ask me. You can unmute yourself and ask me the doubts if you have any queries, any doubts.
হ্যালো স্যার,
Yes.
স্যার একটু ওই বুকসের পেজটা খুলবেন, স্ক্রিনশট নেব।
কোন জায়গাটা?
বুকসের বুকস, ভ্যারি রেকমেন্ডেড ভেরিয়াস বুকস।
ওটা তোমাদের সিলেবাসই আছে।
আচ্ছা আচ্ছা,
ওটা সিলেবাসই আছে এগুলো। এগুলো ম্যাকআউটের যেগুলো স্পেসিফাই করেছে সেইগুলো।
হুম।
So prerequisite knowledge is required to understand this subject. You must familiar with the semiconductor devices. Okay, uh, because it needs from the next day how the fabrication, micro fabrication means the semiconductor devices, how they are fabricated. This technique, in this technique, fabrication technique, you need the concept of semiconductor devices. That is the prerequisite knowledge for this subject, MEMS. So you must gone through the basic knowledge about the semiconductor devices. If you have forgotten about this, you can go through the semiconductor devices, basic principles, and how these are functioning, everything. Okay, so that you can understand easily this subject. MEMS. Okay, do you have any queries?
No, sir.
No, sir.
Okay, one thing I need to tell you that
Hello, sorry for interrupting, sir. I have a question.
yes,
Can you tell me what is the difference between a Scotchy diode and other diodes like IN4007 or
you must go
different
through.
diodes like
You
yes,
must
sir?
go through the. You must go through the basic electronics. Okay,
Okay, sir,
they are.
I've gone through, but a Zener diode is like a Scotchy diode. Uh, Zener diode allows the current to flow from both sides if it's reverse biased, and IN4007 diodes.
I will not discuss
Is,
anything related to these semiconductor devices because this subject is very vast and the syllabus is huge. Okay, so if you have
okay,
any doubt, you must clear it with yourself. Okay, if you have any doubts regarding this subject only, then you can ask me. Okay, not any the analog subjects or any the measurement or the basic electronics. So through today's lectures, do you have any queries? And that's why I'm telling that prerequisite knowledge is about the semiconductor devices. Okay, that will not be discussed in my class. You have to go through that subject. You have to clear it yourself. Now, relating to MEMS and the fabrication of MEMS devices, what is in your syllabus related to this subject, I can clear your doubts. Do you have any doubts regarding today's topic?
No, sir.
No, sir.
Okay, if you don't have, then okay, one thing I need to tell you that those who are in this subject, you must create a group mail. Okay, using your mail ID, you must create a group mail so that uh, that group mail can be used to create a can be used for my Google Classroom, because I need to create a classroom, create a class in Google Classroom, and your group mail must be assigned to or attached with this Google Classroom. Okay, because everything, the assignment, the exam, the lecture notes, the slides, videos, everything will be given on Google Classroom. Okay, so either you can send me individual emails or you need to create a group mail using your mail IDs. Okay, and send me the group mail so that that group mail should be uh, it is added to that Google Classroom account. Okay, and every lectures will be uploaded in the YouTube so that you can listen this lectures anytime, and the lecture notes also can be given to the Google Classroom. So I need to make create a class on Google Classroom. That's why the Google group I need. You must create the Google group mail. Okay, any doubt? Clear?
No. Yes, sir.
Okay, so if you don't have any doubt, so I will end today's meeting. So see you on next week, and within this time you have to create your group mail and send it to me. Okay, thank you all.
Yes, sir.
Okay.
Thank you.
Thank you.